Hello, welcome to this video. It's PVS the tutor and this is Engineers Pro Online School. We have a time graph question here that says the diagram below shows the speed time graph of an object. The object accelerates uniformly from O to OP until it reaches a speed of 20 meters per second in just 4 seconds. Then moves steadily, that means constant speed, for 6 seconds. So 4 plus 6 will get 10. And finally comes to rest in 15 seconds. Sorry, in 5 seconds. So you've seen the motion. Therefore, find the acceleration in the first 4 seconds. Now, acceleration is defined as the rate of change of velocity with time together, right? So you can see that in our case, our acceleration will be calculated as the slope, all right? Now, for the first 4 seconds, that is from 0 to 4, you can guess that our slope is this line there. That's our slope. All right. And you can guess that the object changes its speed from 0 all the way to 20. So there's a change in speed from 0 to 20. There's also a change in time from 0 to 4. So this change in time and this change in velocity, the ratio of this is going to give you acceleration. You now understand, right? Okay. So here's what we're going to do. So initial speed v1 at time 1 is 0. So at this time here, there's time 1 here, there's also velocity number 1 is 0. Everything is 0 here. Okay, so velocity v1 at time 0 is what? Is 0 meters per second. Keep this in mind. Also, we need now the final speed. Final speed, which is v2 at time 2 is what? At time 2 is this time 2. That is our v2. At time 2, which time 2? Time 2 is 4 seconds. Is what? Is 20 meters per second. Okay. Then for acceleration is given by v2 minus v1 over t2 minus t1. Plugging in everything, we have 20 meters per second minus 0 meters per second. We divide by, here our t2 is actually 4 seconds minus 0 seconds, just like that. So acceleration is equal to, so dividing that, subtracting there, we just have got 20 meters per second over 4 seconds. Get 4 there. So therefore acceleration is 4 into 20, it's just 5 meters. Because there are 2 seconds, we square them. That becomes our acceleration. Okay, we go to part B. Part B is asking us to find the total distance covered by the object. So the total distance under a time graph is just the area below that graph. All right, and look at the object that the shape that we are forming. We are forming a trapezium type of a shape, and the area, all right, under the curve, under the graph of the trapezium, all right, is equal to area is equal to base area, base, all right. So we need the base. Okay, let me do this. Half, we need to multiply by the sum of parallel sides. The sum of parallel sides. Then we multiply by the height. So area of a trapezium is equal to half multiplied by sum of parallel sides times height. Which parallel sides? This side here is parallel and that side is parallel to the other side. So we are calling those sides A and side B. So we go half multiplied by, so this side PQ, so we need side PQ plus, we need side D all the way from 0 to 15, all the way from what? 0 to 15. When you get there, just getting 15. Multiply by height. The height is from there, which is this part there, calling the height. It's starting from 0, not from 4, no, but from 0, because the line here is 0, all the way to 20, so we put 20 there. Clear, right? All right, so this will give us 1 over 2. What is PQ? PQ is the distance, is just the length between 4 and 10. Now, subtract 10 and 4, you get 6, plus 15, 20. Half, 21, 20. 2 into 20, 10. 10 times 21, 210 meters. So this is the distance, all right, covered by the object. Together, right? The other one is the average speed in the last 4 seconds. Now this one is a little bit tricky, and it usually carries marks when you hear this if they're not giving you a range where you can easily get that time or velocity. In the last 4 seconds, okay, in the last 4 seconds, we expect from 10, add 4 seconds, it means at 14. We are looking at 14. That's what we're looking for there, at 14. So we are looking for the velocity. There. You go there, then you go like this. So this is the velocity we are looking for there. How do we find it? So let me show you. Step 1 is that we need to find the common acceleration in that region. Finding that common acceleration in that region is going to help us, because acceleration in that line is the same, because it's like the gradient. Points on the same line are usually collinear. All right, so if we know the acceleration in this area, that means we can be able to use this acceleration to help us find that velocity. Since we know the change in time, we can easily get the change in time from there. Is it making sense? Okay, so step 1, let's find the acceleration. But of course, the acceleration needs to be negative because it's sloping down. So step 1, let's find the acceleration in that line. All right. So let's go. So what we're having something like this. I'm just going to relight it here. See, we're having something like this. Okay. We're having something like this, then that. Okay. And here we've got 10. We have 15 there. Of course, this one's coming from somewhere there. This one's also coming from somewhere there. We are looking for velocity at 14 seconds, which is 4 seconds after 10. Okay, it's 14. Is it clear? Oh, sorry. Yes, of course. But in our actual sayings, what we need to do is this. The last 4 seconds, it will range from 11 to 15. 11 to 15 is going to give us 4 seconds. I think you agree, right? Of course, 10 to 14 is going to give us the first 4 seconds before stopping. But the last 4 seconds will actually start from 11 to 15. We need to reach the stopping time. So 11 to 15. So that means, of course, we are looking for velocity at somewhere between 11 to 15. So how do we do that? Okay, so we're looking for velocity between that guy there, that region. So step 1, let's find the acceleration in that region. Okay, so acceleration, we know it's final velocity minus initial velocity. It's final minus initial over time, like that. Because it's sloping down, the 0 here, because it's moving over from somewhere going down. So our final is 0. Our initial is 20. Where it's coming from? Remember, it's coming from 20. So that will be 20 over in the time difference. The time difference. What do you think is a time difference in this region first? The entire region, remember, we are looking for the entire region. It is 15 minus 10. This will give us negative 20 over 5. This will give us negative 4 meters per second squared. It's fine because it is going down, so you are lucky to find the negative number because it is decelerating or it is retarding. Now that we know the common acceleration in this region, that means any point I pick there, it's also going to have the same acceleration. That means if they have the same acceleration, and specifically I'm getting from 11 to 15, it means I can easily find that speed that I'm looking for. Okay, so the only thing that we need to do is simple, because remember the keyword here is average speed. Anytime you hear the word average, it means you are adding some stuff then dividing by certain number. But here we are dividing by what? Remember there are two segments here, and let me show you. So we find speed here at 11, okay? We also find speed at 10. Then those speeds we are going to get them, which are going to help us. But the speed at 10 we already know is that it's coming from 20. So if we know the speed at 10 and the speed at 11, we also know the speed at 15. The speed between 11 and 15 is what is going to give us the time. So sorry, the average speed they're talking about. So this acceleration is going to help us find the speed at 11. So the speed at 11, remember that it's just the speed of the 10 plus its speed. So we are saying it is a speed at 10 plus the new speed, okay? Now the new speed is coming from where? It's coming from acceleration times time, okay? So the speed at 10 is 20 plus acceleration is -4 times time. The time difference between 10 and 11 is actually 1. So the final speed at 11, it will be this, which will be 16 meters per second. So this is a speed at time 11. But we need for the next 4 seconds. Now for the next 4 seconds, it's going all the way up to time 15. So let's find the time, the velocity at 15 seconds. So the velocity at 15 seconds is actually 0 because the line is coming down. So we get 0. So we adding these, so average. So adding this, then we're dividing by 2 because there are only 2 of them, is going to give us the speed that we are looking for. Which is true because somewhere here where we were at 11, or they were there, you're likely to get a lower speed there, which is 8 meters per second. So this is how this question was supposed to be done. All right, if you would like to watch more of these, you can enroll for our classes where we explain at a deeper level, even one-on-one, to make sure that you understand. Okay.